Hello, everybody, and welcome back. For those of you who recently joined, I'm Bandas, and I'm a Senior Web Community Manager at Cognizant Softvision. I'm really excited to be here today and moderate some of the talks that our colleagues from the web community have prepared for you to fully enjoy our web day. This year, at the 7th edition of Programmers Week, we aim to go beyond, to offer you experiences to remember by pushing the limits of technology and innovation. Our next speaker is Alin Dragan, a senior software engineer in our web community. Alin has been a full-stack developer for over 10 years now, and today he will share with us some great insights about software architecture and its impact on the final project. Music and software architecture have more in common than you would think. Alin, the stage is yours.
Thank you. Thank you very much, Anna. Yes, I think the same way music and software architecture has a lot in common. Well, let's just first begin with why do I think these two concepts have in common. Why the melody of software architecture as a title? Because it's important when you start a project to start it well. Otherwise, it will impact negatively the whole future of the project. And I stopped for a bit and made this analogy with the music, with the song. There are a lot of songs that have been made during the history, a lot of melodies, but we don't know them all. Why? Because some of them didn't have the success that they actually expected to have. So I think this is already the title kind of making a link with software architecture. Okay, so why do we make software applications? In general, ideas to solve problems. So I think music solves a lot of problems by itself. It solves depression, it solves anxiety, it solves lack of confidence, human, more at a personal level kind of problems. We don't necessarily solve that, even though it may be, sometimes it depends on the application, but they both solve problems. So why I chose this analogy with music? Because it's the universal language of mankind, as I like to think. It has a lot in common with math. Music is math, actually. It has the logic of math. It uses frequencies, it uses tempos, it uses notations and measures. So it has a lot in common. And we can all agree that math is the true universal language, as many smart people in the world have stated that if God would have spoken a language, that would have been math. So also, maybe you're familiar with the music notations or not, but what we know is that the music uses languages. The way we use languages in our field of work. We use Java, C#, JavaScript. Sorry if I say if I miss a language. Python, Ruby. We use languages, and music uses languages to transmit something, to make something from an idea to an actual product. So that being said, I would move forward and let's see why the word melody. Because, okay, you said something there about the analogy, but why melody? Because the melody is a sequence. The definition is a sequence of single notes that is musically satisfying. That means that you grab a bunch of notes that, taken by themselves, they say nothing. Actually, they may be boring. But if you put them in a sequence, they will, in the music at least, they will wake up feelings or memories or something. They will transmit an emotion. The same, I think it's applicable to our field. If you take lines of code one by one, they won't say nothing. But put together, you will have an application. And we all use today a lot of apps on mobile, web, and not only us as users, but also big companies for tooling and everything. They all use apps, applications. And so now that we may see some pattern here, right? Melody, sequence of lines. We have a lot of melodies usually in our applications. Now, maybe you all, what does music have to do with the software architecture? I already said that, in my opinion, it has a lot, but the most, I would say, the most common things that have in common are these. Some common points. They're both creational patterns. They use instruments. They need a general idea to start with. Some form of preparation and planning, appreciated by an audience, and they consume resources and they make even music. I know it may seem that an artist or composer may compose it on a piano, on a guitar, the song, but if that artist wants that record to be heard and listened by people, before the internet and personal computer, there were the concerts, and this was the only way to actually hear the creations of others. Now we have Spotify, so it's much easier. But okay, let's make the links. Let's try and make these links one by one. Creational patterns. I guess we can agree that they both do things. They create out of sort of from scratch. When we make a song, we make it from just a bunch of notes. And when we make an application, we make it from a bunch of ideas. It starts from some notes, some sketches. I guess this is pretty simple. Now, the part that I like in the analogy, the instruments. Do we have instruments in software architecture? Yes, I think we do. Obviously, in the music field, we do have instruments. The important thing is the point in the software architecture if we have instruments. The instruments in software architecture, I consider them to be diagramming tools. I consider them to be the wireframing apps. Whatever app helps us to, even drawing app. I've seen some apps showing up today that just lay out ideas. That could be a tool. Confluence can be a tool too. Libraries. You may use React.js to just show something, how it's going to work, or how you propose it to be like. And from this idea, I would like to say that the biggest instrument that the software architect has in his backpack is the concept of POC, the proof of concept, the proof of concept. Yeah. Why the POC? We'll dig up later on that, but I think the POC is the most powerful tool that a software architect can possess. So, yes, I think we use instruments in software architecture. The general idea. We need a general idea, something that we can start from. Even though someone, the client, already told us, okay, we want that, but you need to have a general idea of the whole, how you're going to start from, the starting point. So it's always good to have a big picture of, okay, I want to do that. Maybe a phrase, maybe a proposition, something that will say, okay, we're going to start from that. Okay. The creational mood, yes. The creational mood in software architecture. I've seen this in my experience that sometimes architects had great ideas, and in the meanwhile, something was going wrong. They changed something that seemed very good out of, I don't know why. And I may be thinking that this is due to the creational mode. we're not feeling always creative, right? We don't feel like we have a good mood to do things. Okay, how we're gonna architect this system? How we're gonna start from the inspiration. So how to solve this? Well, we play those instruments that I talked about. We play with POCs, and the mood, the creational mood, will come. If we waited to come just by doing nothing, I don't think it's it's a good solution. It may be late or may not even come. So you stimulate it a bit. Okay, the planning. The planning is part of our lives always. And in music, there is planning. Maybe the first impression is that music, oh, it's no planning. You just not is playing the instrument, then he found something. But imagine if you found a good melody, a good riff, you have to memorize it and you have to expand it. We all know our favorite songs and we recognize them by their main riff, their main melody. But that's not it, because otherwise it would have been 10 seconds or 20 seconds. So you have to expand that and come with a broader set of notes and chords and chord progressions and whatever tools you have in music. So it's applicable to software architecture too. Okay, you start with a good general plan. I don't know, you made a flow chart, but that is not necessarily, well, a flow chart depending the size, but let's just say you have a general idea of the architecture, but that's not sufficient. You need to dig up a bit more and make sure that all the things are linking up nicely, pleasantly. A good melody has a very good way of, taking you from the start, an intro, then to the verse, the chorus, and it's like a story. So a good story, everyone enjoys a good story. And also, yes, you will not be caught by surprise by unpredictable issues if you just have a plan. I mean, you will find unpredictables, but you will digest them differently. Yeah, this process is a bit of time consuming, and I've seen that not everyone takes their time to actually make a good plan or a bunch of plans. You can make more plans. Actually, I believe that more plans, better it is. Okay, I just like this quote from Freddie. He said once that his melodies are superior to his lyrics, and he worked a lot on his lyrics, but I think he worked more on his melodies. This is what I understood from this, and this is the importance of a melody. For example, most of us don't remember the lyrics. For example, I'm terrible with lyrics, but I remember the melodies. I remember how it sounds in my head. So if you want to make an architecture that is going to be memorable, it has to have a good melody. Memorable in our way it's not going to be played on the radio. It's going to be used by users, but it's a similar concept. So you have to make a good melody or a set of melodies, of course. How to get good melodies, we'll get on that in short time. But the idea is that you need to grab as much pieces of information as you can. Usually a composer or someone, a songwriter, listens to is inspired by other artists. For example, Eric Clapton was inspired by B.B. King. And if you hear his way of playing, you will see that it's very similar, if not the same technical details from B.B. King, and so on. Most of the artists have been inspired by something or some other artists. Okay. Now to how can we have a melody? But before we get to how to have a good melody, there is one piece of comparison that we haven't talked about, and I would like to talk about that: the audience. Because the audience, what has to do with our architecture business. Your first audience as a software architect is the team that you're working with and the client. Actually, I would say more the client than the team, but the team in equal manners, because they will enjoy it. Why I say that maybe only the client, because for example, Nirvana's song Smells Like Teen Spirit, the band hated to play it, but everyone loved it. So it was, the team didn't like it, but the listeners liked it. So the audience, we have an audience as architects, and the first audience is of course the client and the team, but then the audience is very, how can I say, very harsh and a bit bigger, because the user, without any harm intentions, it will judge what we do. Even if it's a tool, an internal tool, it will judge that. I mean, I don't like to use this application. It's not user-friendly. It's not intuitive. It's harder for me than actually doing it, I don't know, the other way around. So, yes, we have an audience, and we have to treat that audience carefully, just like a songwriter does. This is why the songwriters and composers, they spend a lot of time before actually shipping something, because once it's shipped, it's going to be judged by that audience. Seems a bit risky, but it kind of is. You will be judged by someone. Judged, I mean, not in a bad word, but they will say their opinions, and that opinion will influence the fate of what you did. So how can we have a good melody? How can we have a good architecture? Well, how I would like to solve this is by using one type of analysis. During my experience, I've tried this type of let's just say algorithm of way of thinking, but also the classic one. In software architecture, the classic way of doing it is you start from bottom up, meaning you start from what the client requested, you start from the requirements, the functional and non-functional, which you find from the client too, meaning what the system should do and what the system should deal with. And then you build up. And this is the classic way that we actually do. You extract some components, you link them together, you find some issues in the meanwhile, most of the time, some limitations and other nasty things. But how I found in my experience that it's even better and more enjoyable, just like in music, to be enjoyable, to enjoy doing that, is to use a concept called means-end analysis. What means-end analysis says is basically starting from an end goal. So the classic one starts from bottom. This one starts from actually the end. So you envision an end goal. I will give a practical example too. This is used in music a lot. The concept actually, the documentations that I found say that this concept was actually invented in the 1950s, but in music is used from much way ahead than 1950s. In music, we call it the return home. You start a song with the melody to catch the ear of the listener. You tell the story, and at the end, you go back to the initial. So basically, the end is the starting point also. How can we do that in software architecture? Well, let's just grab a simple example. let's just say that we have a dashboard to make a dashboard. Even nowadays, the dashboard is very requested type of application. Let's say you apply a lot of CRUD operations on a set of data, some databases, some, I don't know, data from Elasticsearch, something like that, read, delete, update, and you have to make a dashboard. You can start from bottom, where you extract the functional and non-functional components, which you will eventually, nevertheless, but you can also start from the end. The benefits of that is that most of the times the clients are not, or the ones that propose these solutions, that they need these solutions, they don't have a very clear picture of everything. And it's normal to not have it, because that would mean that you know the future. But they know the general idea of it. Okay, we need a dashboard to manipulate those data. Then you can start with the dashboard. You can start with the dashboard, draw it on a piece of paper. I know, use Draw.io or just a pencil and a piece of paper. And you make it. You make the headers, you make the rows, you make what buttons do I need here? Oh, I would need a delete button, or need an edit button. Okay, on edit, should I show a modal? Lay out all those ideas. I can show a model, I can change the page. I can have it underneath, nested, or on the side. Do all that. And that means actually okay, this is the app, but to go there, this is the means end analysis, how we go there. And now you start the journey. What do we need to do that? What do we need for that dashboard? Are we going to use a grid, a table? I would say grid is more modern. The headers, how many columns are we going to need? The rows, what the components, what are the components that we need for the rows? And you already have a lot of paths now. You see a lot of trajectories that will lead you to the same dashboard, right? And this is one of the benefits of actually using this reasoning methodology, that you see a lot of paths opening up to you. You can use that, you can use that, you can use that. I'm not saying that if you start from bottom up, you won't have, but you will have to play it, just in your head, like it's not, in my opinion, it's not so natural. Because with the means end, you already have, okay, I have to go there, I have to go. And there's a bit powerful motivation for our brains. And this is more natural to us. This is how our brains work. We need to know the destination to go there. Otherwise, it will be just a walk. So you have alternative paths. You will find obstacles because if you already know the end goal, you have drawn all your dashboard. When you try to extract those components for your architecture, you will see some obstacles. Oh, but here the client said that we cannot do that because we have these constraints. We have to use these libraries to integrate with that system or something like that. And the most important, so you will find obstacles. And the most important thing that I consider to be that helps you is that you will gain control over the negative transfer. The negative transfer is, how can I put it, the urgent important table, if you're familiar with that. Meaning that there are things that are urgent and things that are important, and don't mix them up. For example, I've seen situations where solving a problem initially caused a lot bigger problems and technical debt in the future. Thinking scaling your application for billions and trillions of users, even if it doesn't need to, will cause you a lot of problems, for example. And that's a practical example that I've encountered sometimes. So try not to solve problems where they're not there. And this will help you to have an end goal, something. And also, for example, it's urgent for me to drink water, but it's important to go to a meeting tomorrow. I will drink water first because that's urgent. Otherwise, I will feel bad or something like that. So keep that in mind, that the urgent things must be dealt with first, and then the important things. And I think this means end analysis helps us. It's also an AI algorithm used. It's not only a conceptual thing used by engineers, but also an instrument of artificial intelligence. And I think it's very useful. Also, once you've done with the means end analysis and you have something, you have some, I don't know, three roads that you can take, then chunking those paths. Chunking is always a good tool. You will take each path and divide it. We use this in dynamic programming to chunk a problem in bits and then solve the bigger problem, or divide and conquer, as some would like to use. But it's a very powerful tool. And I think the chunking is better when you already have something to chunk with, right? Because if you start from something and you don't have material, what do you chunk? We don't. And let's make some analogy with the music, right? Because we haven't done that for the means end analysis in music is used to, you start from an idea of a melody, but usually that idea is not the final song, not even close. Sometimes it is, but most of the times no. So you envision, usually the artist envision the whole song. Oh, I would like here to start with a guitar, then a bit of a flute. We go crescendo, we go up, drums, bam, bam, bam. And you will see that actually there's some manuscripts of the Beatles, of famous bands that actually they thought this way. They had a script. Okay, now Paul plays in, then Ringo jumps in, and so on. So they use that and I think they use that in the classical music for the composition of orchestral too, because when you have an orchestra, you need to be disciplined. So means to an end. Yes, to envision how do I see that song to be? You have to use your imagination, yes, and that's a good thing. That's a creative thing. That's now. Okay, I spoke to, but I didn't change the slides, but basically that's what I talked about. Okay, now this is the subject that is very, in my opinion, useful to know about and to put it in practice, because unfortunately I've seen that it's not that used as much as I would think it would be useful to use it as an instrument. I like to see the POC as the piano of software architecture. Why the piano? I would say is the king of instruments, although Mozart will contradict me and will say that the organ is, but seeing the size of an organ, which is a building, I would say the piano is better. I would like to play the organ, but they will kick me out of the church, and it's a big instrument. The piano, it's a bit more accessible. It has 88 keys. This is why it's called the king, because it has basically all the notes that our ears can perceive. It's very linear. You don't have like the guitar or the violin, where the guitar you will have to use both hands, but you play only with one. The violin, the same. You use both hands, but you play only with one. No, the piano, you use both hands to play notes. So that's a lot of power. And also the sound is a very pleasant sound. It's a resonance. It's a resonance sound, like something in between a string and a wind instrument. And why the POC? I think it starts with the P, by the way. I think it's the piano or the king instrument for architects. Because with the POC, you can see if you're right. You can see if your idea of linking some, I used already the term chord progressions. Basically, it's a bunch of notes together that in a progression, they form something pleasant. So in architecture, you see that the little tiny bits of components and how they function individually, they link together uniformly. Let's just say, keeping the dashboard example, you want to see how the rows are being rendered when you paginate and when you use the pages. You want to see how the search function. Just do a POC even before having that functionality implemented. Okay, I want to have the search functionality. Do I want to see the results? Do I want to display the results in the, the input? Maybe that's not a good idea. Do I want to see the results in real time? Do I want to use a button? Making a POC, something simple. You don't have to, use a lot of CSS or something like that, but prove that concept. You want to, I don't know, parse a file, CSV or something. Make a POC. See, okay, how it handles with this type of data. What if we have bigger files? Can we use, I don't know, something like streaming? It's better to use it on a client, on a server side. And you can make those POCs pretty easy. Just a console application, but I consider them to be very important because once they correct your mistakes, and you don't bring those mistakes in the project, because once they're in the project, they're on the radio, it's very hard to correct them. Actually, in music, it's impossible. But we may have a solution in software architecture, actually in software business, because we can make hot fixes. But that doesn't say that the melody was good. So the proof of concept, yes, it's a very versatile instrument that I've seen. It's not that used, and it's a bit of a shame, in my opinion, that we can use it more. I've seen it used to in many situations, but not as I would prefer. So that's the piano. I think you see already the linkage between music and the melody. We may have for a project, we may have a lot of melodies that put together, they work like a symphony, like an orchestra. Imagine that in an orchestra, if let's just say classical music, if you go to a symphony and you listen, trust me, if someone doesn't play well or something doesn't work, you will hear it. You will hear it, and it will kind of ruin the whole act. So it's pretty much the same with software architecture. If a system, a bit of, let's just say the registration doesn't work, but if the login doesn't work, well, that's a big problem. So yeah. And now for the bit of time remained, the software architecture documentation. I know it seems, well, obviously you have to make that obviously, but well, I've found projects that haven't been documented at all, or have been, lazily or very, superficially documented. And this is like hiding your song. Like, you know how to play the song. You're the band, or you're the artist that actually plays it, but that's the only person that knows. So basically, if someone wants to play that song, to make a cover, or to, inspire from that, because you can use it as an inspiration, they'll have to reach you if you don't have those music sheets, right? If you don't have the music sheets, you can find the music sheets for everything. You want to play guitar, well, install Guitar tab, and you'll find all the songs have been played on guitar or piano or something like that. And in software architecture, we have the documentation. If somebody grabs this project as an inspiration, maybe he has some needs, maybe that are similar to what you've done. If you don't have a good documentation, then you won't, the other persons won't be able to actually understand. They have to do some sort of reverse engineering, understand and listen to it. And in music is the is a hard thing too, as is in, I mean, in software architecture or in software, in IT business, in programming, if you do a reverse engineering to see how an application works, it's pretty hard. You know, you have to look into, okay, how this does is, and time consuming. And in music too, if you just listen to a song, there are some persons that they can do it like, oh, it's a key of C. Okay, right. But actually the right notes is pretty hard to actually, you know, get them. So it's very important to document the architecture. So as a closing, we're getting towards the end of this whole idea of music and software architecture. We are kind of composers. When we make an architecture, we are composers. We make the only difference is that we don't use musical notes. We use diagrams. And if we use the POCs, we use some lines of code to just prove those diagrams. We use diagrams, we use proof of concepts, we use presentational tools, wireframing tools to show that. But in the end, we're composing something, we're making something that is going to be enjoyed or not, and it all depends on us how to do it. So hopefully you've enjoyed this analogy and this comparison of both the concepts of the music and the melody. Why I chose the melody, because the melody is the thing that you remember. There's also harmony in music, of course, but no one actually remembers the harmony, and it's not that, you know, memorable. The melody, the main riff, the main thing, that's memorable. And in software architecture also, the melody will be remembered. And the melody is basically that, or the melodies, they can be more. Those workflows, they're fluid. They just, you enjoy using the app. It happened to you to actually enjoy using an application. Easy, intuitive, and fast. And I think so. The next slide should be thank you. Yes, and name and date. My name is Alin, and the date is yeah. Okay, didn't check that. Thank you. If you have any questions, I would leave Anna now to continue.
Thank you, Alin. We do have some comments and some questions from the audience. So one question from Vlad. I've heard an interesting point that even when writing a POC, you should write your best code because POCs tend to not be thrown away. What's your take on this?
Sorry, my internet has, yeah. Please, what I missed.
Okay, so we have a question from Vlad for you, Alin. I've heard an interesting point that even when writing a POC, you should write your best code because POCs tend to not be thrown away. What's your take on this? Yes,
because he's right. Because imagine Paul McCartney. You think he would play bad when he makes the POC? Oh, I have this Let It Be song, but you know, I want to continue with some chord progression. I grab the guitar and I'm like, nah, nah. No, he's not. He's going to play good because he plays good. So Vlad, yeah, you're perfectly right. You have to write the best code, but not the biggest code. So this is the difference. You don't have to make the whole application, but the best code, yeah.
Thank you, Alin. And also from Vlad, what's the song corresponding to your favorite project?
I would like to say Stairway to Heaven, but I haven't reached that yet. So there's no Stairway to Heaven yet. Bohemian Rhapsody would be. It was a project like the Bohemian Rhapsody. Very, you know, energetic and fun. And it was like a trip, you know, like a trip to something good. I mean, so yeah, I would say Bohemian Rhapsody. There was a project with the Bohemian Rhapsody. Unfortunately, like all projects, it ended, but well, we did a good job.
But like Bohemian Rhapsody, it stayed in your memory.
Yes, yes, yes.
Okay.
But I'm expecting Stairway to Heaven to appear near the corner.
Okay, good. These are the only questions that we had from the audience. Also, Bogdan mentioned the comment that means and looks very similar with the backend engineering. Do you agree?
Yes, yes. Being a full stack, I actually started as a backend. So yes, the backend engineering is very much, but this is, and he pointed right. The backend engineering works this way, but the front end starts like, hey, but I need to know the components, and that's a wrong thing because the front end should do the same. You should see the whole, but it's tricky because you need, oh, but I need the login form, I need that. Imagine, use your imagination. So yeah, he's right. It's a very engineering used concept and analysis. So should be. It is true. Yes.
Okay. I have a question actually for you, Alin. So you are playing some instruments yourself.
Yes.
So I am very curious to see what was your latest composition based on. I don't know if maybe a project you are working on has actually inspired you to write a song yourself.
I actually do write some songs as a fun yet. I don't know if they're gonna be public, but well, to be honest, I write some pop songs most of the times. What's modern? Haven't dealt with classic rock, even though I like more classic rock. But I did actually have an instrument right here with me, and sometimes I get some riffs and ideas. This is the POC instrument. Yeah, maybe. So when you have some ideas, you just strum some. Yes. I do have some projects. Yes. You want me to show you some ideas that.
No, it was just a question to make sure that you are doing the reverse engineering part as well. So
yes.
From the project.
Yes, actually.
Wrote music.
Yeah, actually, I reverse engineer a song. I didn't know which key was, and I tried. I mean, I'm not that good to recognize a song, but it was something like this. It was, I remember, from the something like, I don't know if you can hear it, but it was you see this progression here. I didn't know which note, and I had to like make it, and I had like reverse engineering. But the first note is always important in music, and then you can come up with the next. So if you know the first key, then you can build your way up. Maybe improvise and ruin the whole idea in behind, but yeah, you can start from something.
Great. Even though the audience probably haven't seen your guitar fully because of the
it's
because of the background, I'm sure everybody heard it, the chords. So well done on that one.
If I show the background, is you can see my kid's bed and the toys and this. Yeah.
Don't worry. We have actually another question from Flavio. Yes. Can behavior-driven design or test-driven design help in driving the architecture?
Yes, actually, both of these concepts, they use means and analysis in the origin. Because imagine that, let's just say TDD, test-driven. You have to write tests first, so you have to see the go. So yes, of course. Although I would actually recommend having something before and then, so sort of a hybrid situation, test-driven development, but having something initially to start from, and then you write the test first, and then, because I seen that it's more it's easier to do that, because when you start just with TDD, you may consume more time, but it's the same philosophy, yes. And behavioral, of course, because it's obvious. It's how it app should behave. So it's the means end. Yes, hopefully that answers. Oh, that's good that you can hear the guitar. Nice. That it hears well. It's actually a pretty basic microphone, so it's nice. Yeah.
Yes, everyone was able to hear that, right? So thank you for that short insight. We are looking forward then for your first official song. I hope you can share it with us in the web community, and maybe in the next
Yes.
Programmers Week, you will do a continue to continue the series and this talk with more insights about.
I don't want to let anyone down, but it's not going to be a classic rock song because basically it's very hard to beat those. I mean, really, it's so going to be something modern, you know. The Weekend, Dua Lipa, something like that. You know, with, yeah, a lot of drums.
We'll see your next featuring then there.
Well, hopefully, who knows? Who knows? But my main job is going to be software engineer until further notice.
Okay. It doesn't seem like we have any more questions. So, Alin, thank you so much for this great insight and this great talk on comparing the music and the software architecture.
Most welcome.
We enjoyed your first talk here at Programmers Week. So thank you again.
Thank you. Thank you.
And we will take a short break again, and we will see you here with our feature talk here at the web stage at Programmers Week.
Thank you very much to everyone, and let's have some good melodies in our code. Thank you.